you doing?
Hello.
Do you have any questions? Just want to make sure I configure my microphone here. So we are going to do the lab today. Let's check out the lab and get your simulator open. Get your code ready. We're going to work a little bit with control statement today. So let me check my share screen here. We're going to do lab 4. We'll start in a few minutes. I sent out a flyer for Data Science Fellowship. It's open to all RCCD students. If you want, you can also check out the announcement in the announcement board. And we have info session on the 23rd. The application is going to be due by March 31st. If you're interested, you can fill out the application. If you'd like to get more information about the program, you can go to the info session. UCR faculty and RCCD faculty, including myself, will be there. I'm hosting the event. If you go through the fellowship program, it's $5,000 stipend for the students that qualify for that and complete the program. So if you look to pursue data science, it's also a good learning and working experience. You have real project with employers. Let me show you where the announcement is at. And you probably received it in the email. If you haven't, that's the first one. This one has the UCR application. And then if you check out the announcement, the info session will have that on the 24th. The info session is on the right and the application is on the left. Okay. Okay. So let's come back to our lab for today. We're going to do lab 4. We have a quiz, don't forget, and then you can use the extra credit game to study for it or prepare for it. And if you score the highest, you get a gift card for the game. Okay, I'll go ahead and get started since it's 6 o'clock. People will join us shortly, I hope. So in this lab, we're going to cover some of the concept from chapter 5. We talked about different type of instructions. We're going to work with the simulator today. So whether you're using the online one or your application that you installed on your Windows system, you can use that. So I'm using the editor and the simulator for Windows PC. We are going to go to a certain address location like what we've seen in the past, but we want to focus a little bit more on branching this week. So I want to show you how you can write a control statement in LC-3, and we're going to look at the other instructions for operations and data movement as well. Some of the things that I want to note before we start, I did put it on the assignment page. When you're looking at the simulator, like we said before, be careful with what you are looking at the register because they don't store permanent data. At the end, after you ran your program, your R1 is always going to show -1. This is just a way indicating that there is that it's terminated. The program is complete after it ran. So when you set your value to test, make sure that you go to the address location like what we've done in the last week. So you are going to find the address location and you're going to set the value. Okay. I also included some of the link. This is the lab manual that I referenced. It's used by many universities. So if you want to check out how it is, I added some stuff and I modified some things. So it's not exactly like it, but if you want to look at the lab manual, you can. So for our lab, please refer to the document that's provided on the page. And in this lab, we are going to use the instruction. So the first part is we are going to work with arithmetic functions. And simply, we are going to have two variables, x and y. And we're going to set the location for these variables. And that's the requirement is x is going to be at hex 3120 and y is going to be at hex 3121. So right away, we know that this is going to be a fill location where we're gonna set up our x and y label. And for our function, we want to operate the subtraction. So we are going to take whatever the value is set for x, we're going to subtract y. And we're going to put the result in the subsequent location, which is hex 3122. Now, our problem also asks us to treat x as an absolute value and y as an absolute value. And based on mathematical concepts, we know that whatever that you set for x, it's going to be treated as a positive because it's absolute value, and same thing for y. But because it's absolute value, we want to place it at another location so we can test, which is hex 3123, and y is going to be at hex 3124. So you are going to treat x, regular x, different than the absolute value. So we're going to fill them appropriately as labels. And we want to do a comparison. And this is when if else statement comes in, or in our case, in LC3, we are going to branch. So we want to look at absolute value of x and absolute value of y. And we're going to compare the values to see which one is larger. So if x is larger, then what we want to do is we want to place a 1. So it's going to indicate a 1 at location 3125. If y is larger, it's going to show a 2. And if they are exactly the same or equal, it's going to show a 0. And comparison is really easy. As you saw in the last lab, we're simply going to operate subtraction there when we compare. Okay, and then we're going to branch. So if I take x, subtract y, if I have a negative, it's going to show 2 because y is larger. If I take absolute value of x minus y and it's equal to 0, right, then it's the same, then I'm going to indicate 0 at this location, hex 3125. And if I take absolute value of x, subtract y, and if I get a positive value, then I know that x is larger, and then it's going to put a 1 at hex 3125. So in summary, this is kind of what we need to establish as far as fill in addition to the other two. And so with that, we want to define Z. And Z would have these conditions, just like what we stated above. So this just going to represent what we said earlier about filling the location for 3125 and indicating the value based on the comparison. So if it's greater than 0, we put a 1. If it's less than 0, we put a 2, right? And then this should be a 0. Sorry, I think that's wrong there. A 0 if it's equal to 0. So let's talk a little bit about branch before we approach the code. In the lecture this week, we touch a little bit on branching. And so branching, the way we use it in LC3, we are going to use BR. And this is a way that we can change the sequence in how our program is going to flow, but it's a way that we can implement control or control statement in our program, like if else. So if the result is in the previous instructions, so when you're taking a look at, let's say if I have X is at R1 and Y is at register 2, R2, and I operate the subtraction, and if the result is equal to 0 in R3, then it's going to look at the register that store the output, and if that's equal to 0, then it's going to branch to the label for the 0. And so if it's not equal to 0, then it will follow the BRC target and execute the instruction in the next line. So branching is really a way that we can send it to a section when it meets the criteria or when that is true. So when I say that BR00, then it's going to go to the label 0 and it's going to execute the code there. But if that's not true, it's going to go to the next line in my code and execute that. So the condition of branching really depends on the bits. So the N indicate negative, Z indicates 0, and P indicate positive. And these are the 3 conditions that we normally use with branching. But as I mentioned in the lecture, branching can also be unconditional. And when you do a branch without the Z, the N, or the P, with just the BR, what it is it's just going to go to the label regardless. So that's equivalent to a jump. That means that we're just going to send it to the label at that point, and it's going to execute whatever that we state in that label block. So in the low level, you are going to use 0 and 1 to really indicate the condition bit. So think of this as in your higher programming language, you can say if this is true, which is 1, you're going to execute the body of that condition statement. If it is false, which is else, it's going to execute the else. And so when it's false, it's going to check for the 0. So very closely related to that, what you see is you're going to see that the conditional bit is used as 0 or 1. And that's going to determine the destination, or based on the destination register, your result storage when you operate subtraction, addition, or whatever it is for the arithmetic right for the line above it. So when we look at this example, this is going to show us how we can branch to the label using the 0. So when I look at these 3 lines of code, I can see that, okay, I clear out register 1 by doing an AND 0 here with register 1 and store my result in register 1. So register 1 is 0 at this point. And then I want to add 1 to register 1. So I would have register 1 plus 1 and put that result in register 2. So in this case, it's going to go to register 2 and it's going to check for the output here to see if it is meeting the criteria. Is it 0? Is it positive? Is it negative? And if it meets the right criteria, if it is equal to 0, then it's going to go to the label. In this case, I put 1 into the register 2, so it's positive. It is not going to branch to the label because it is not 0. So what will it do after that? It's going to not go to the label section. It's going to go to the next line after the BRZ to execute that line. Okay? Any question? Okay. So here, I put a little chart together for you as we talk about BR for unconditional branch. BRZ, BRN, BRP. In some cases, you can combine the condition negative and 0. So if I want to do equal, or I'm sorry, less than or equal to 0, we're going to do a BRE and NZ. If we want to do 0 greater or equal to 0, we're going to do ZP. And we can also do negative and positive. So it's going to skip the 0. So if the value can be negative or positive, but not 0, then we're going to do the NP. And then sometimes we can use NZP, which is the same as BR, because it's gonna jump no matter what. It's gonna branch to that area no matter what it means. So when you combine the 3 like this, it's equivalent to the BR. So the example, and I pulled this from the lab manual. So let's say that you have your input, and a lot of the times they give you a hint on how you can derive your program by looking at this example. Your input is going to be R1, and that's your X. Your output is going to be R2, and it has the absolute value of X. So in this case, I take X, I add it with the 0, and I put it on register 2. So basically, when we see that when we add a 0, that's a copy, right? So we take X plus 0 and put it on register 2 as the result. So we copy the content of R1 and put it on register 2. And so now what we can do is it's going to check the content of register 2 for the condition. In this case, it's going to look for 0 and positive. So we're looking for basically absolute value, right? It's going to be either equal to 0 or greater. So if it is, it's going to go to ZP. And then we're going to operate the 2 complement. So here is where we take register 2 and we set it up for the 1's complement. And then we add the 1 so it becomes a subtraction or a negative. So here R2 is going to be negative R1, right? And so at this point, R2 is absolute value of R1. So if it is going to go to the ZP, that means that it is an absolute value. If it's greater or equal to 0, it's going to go to the ZP. And it checks that from register 2. Okay. So that kind of give us a little snippet on how we are going to build the program. And then what I did was I took a snapshot of my program. So you can always expand it to take a look at the code, as sometimes it looks kind of tiny. So in your editor, you are going to write this program and you can add the comments, which I did. Okay. So let's start with the top. Let me see if I have it in Word so it's a little bit bigger. Give me a second. I don't. Okay, that's fine. So we start with the origination address. Well, let me put this in Word so it's bigger. Okay. so you can see better. I know it's really hard on Zoom sometimes. All right, so we start with the origination address, and make sure that you put this into your editor, okay, like text edit, Sublime, the editor of your IDE, and then save it as the .asm when you write this program. So we are start with the origination address .org hex 3000. That's where your program begins. And we have to work with the two variable first. So we have my X and my Y. So this is my label. So I'm going to load X to register 1. And in this case, I'm using an LDI for indirect load. So I'm loading X to my register 1. Oops, sorry, type C there. And I do the same thing for my second variable, which is variable Y. I load Y to register 2, and again, I'm using LDI. Then I want to operate the 2's complement like what you've seen in the example snippet. And in this case, I'm taking X and I'm subtracting Y because I'm doing a comparison. If the X value is larger, for example, 5, and the Y value is 4, when I subtract, I should have a positive. Then I know that X is bigger. So that means I have to subtract Y. And so because Y is loaded to register 2, I'm going to go ahead and not register 2 and put the result in register 4. So this is the 1's complement, and we would negate, getting ready to negate register 2 and put into register 4. And I won't be able to complete the sign value until I have the 2's complement. So in the next line, after I not R2 and put it on R4, I would take R4 and add it with the 1 to complete the 2's complement. Okay. And R4 at this point would be negative R2. Or that would be negative Y. So after that, I need to take X subtract Y. So X is at register 1 and negative Y is register 4. So I'm going to go ahead and add them. So that means X plus negative Y and put the result in register 3. So my R1, I added with R4 and place the result into R3. So my R3 is X minus Y. Now I want to check the value. So at this point, I want to take what's in register 3 and put it to an address. So that way I can see. So here is where you're going to store. As you load earlier, we want to store out to the address so we can see. So here is where we're going to store the content of register 3, which is X minus Y, to a label, which is tied to an address. And my label is XMY for X minus Y. So I store register 3 content to XMY, and XMY is the result from X minus Y. And that is tied to an address, this label. So I can use my simulator after I ran the program and set the value, right? I set the value, ran the program, and I can check. Now, what we're going to do next is we are going to set up the condition. So what I want is I want to copy the content over. So here is my X, which is from the top, my register 1, because I didn't clear it, it's still there. So I want to copy X and I want to put it on register 4. Okay. So at this point, my register 4 has X. And what I want to do is I want to check, right, to see if X is greater or equal to 0. Why am I doing this? So I'm going to take you back here, right? What we want to do is we want to set up the absolute value of X. So because we already did this part, we want to go to the next stage now where we have to make X as an absolute value. So that's going to be 0 or greater. So that means that I have to make it where I can check the register content and see if it is 0 or positive. So what it's going to do is going to look at register 4 and it's going to check for 0 or positive by using these bits, condition bits, ZP. And if it is, it's going to go to this label called ZPX. Okay. So 0 positive X. And I put here that branch positive or 0 from the result of R4. And then after that, what we're going to do is we're going to set up the 2's complement for X. So that way we would have negative X, because if you take a negative value and you put it into the absolute value, the absolute sign, it will be converting that to a positive. So I can have -5. The absolute value of -5 is going to be +5. So what I want to do is I want to treat it as a negative number as well. So that means that I have to sign it. And when I sign it, I can also check for, I can make it into positive by checking for positive, right? So here is where I would have the 1's complement because X is at register 4 before the branching. So I'm going to not register 4 and put it on register 4. And then I'm going to add the 1 to it to finish the 2's complement. So R4 is going to be negative X for the absolute. Any question? Okay, so now we are going to start, right, the definition for our condition. Because earlier we send it to this label, ZPX, we have to define that label now. Now, in LC3, it's not particular on how you write your label. You can have it this way, or you can have it to the left of your instructions. You know, just give it some space. And so that's up to you. So in this case, what I did was I just start the label here, and then all my instruction following that is part of this label. So for my label ZPX, this is going to be absolute X. I wanted to check for the value for my X as negative, right? So I store it out. I store the content of register 4 because remember, register 4, right before the label, you see that it is negative X, right? And we can have a negative value for the absolute. So when we put it into the absolute sign, it's going to make it positive. So we're going to store the content of R4 to ABS X, which is, it stands for absolute X. And then what I'm going to do is I'm going to now use register 2, right? Recall that when we did earlier, we load Y to register 2. Okay, so register 2 is Y. And we're going to copy that to register 5. So the content of register 2 is Y. We're going to add the 0 to it and put the output in register 5. So register 5 is also Y. So Y to R5, we copy. And for the comparison, we want to check to see if we do X minus Y, right? So we want to check to see if X subtract Y is a certain value. Is it 0? Is it 0 or greater? Or less, right? So here in this one, I'm going to check to see if it's 0 or positive. And if it is, it's going to go to ZPY. So where does it go to check? Register 5. Okay. So we want to see if Y is 0 or positive, and it's going to find the content of register 5 to check to see if Y is greater or equal to 0. If it is, it's going to go to ZPY. If it is not, it's going to go to the next line. Then after that, we are going to begin the 2's complement of Y. So for register 5, I simply knot it. And then I add the 1 for the 2's complement. So register 5 would have negative Y. Now for the branching condition, when you go after you send it to the label, when it completes, the program counter is going to have the address of the next line. So it's going to pick up where it's left off, which is the next line here. Okay, so even when you send it to the label, it's going to finish what's under the label or at the label, and then it's going to come back to the next line in the program. Any question?
Yeah, how do we turn the negative value into an absolute value?
So the absolute value we check for positive. So we're going to make it a positive. But you have to know that inside the absolute sign, that value can be negative. Okay. Yeah. So what happens is when later on you're going to see that we're going to take that negative value and then we're going to make it 0 or positive. Okay.
Okay.
So yeah, we're going to convert it. I'll show you soon. Give me a second. Okay, so now what we're going to do is we are going to look at ZP. So 0 positive Y, because we set up the branching here, you have to define the label. Because if you don't, your program will not assemble because it's going to look for that. It's going to say, oh, I don't have that, right? So if you have a label that's tied to a branch, you have to define that label. So here is where we're going to do the absolute Y. Just like before with the X, we're going to remember that we left off with Y in register 5, right? So we're going to store register 5 to an address, which is ABSY for absolute Y. Why can't I use register 2? When I first loaded, it was register 2. As you go through the program, you are going to apply arithmetic to Y different ways. It's better that you copy it to other register instead of using the original register. So that way I can reuse the register 2 in a later part of my program instead of reloading it. Because when you reload it at some point, sometimes that could be different. So you want to make sure that your original registers stay intact with that label, and then you copy it to other register and use the copied register to apply arithmetic throughout, and that's what we did with register 4 and register 5 for X and Y. Okay. So here is where we store out for our absolute Y. Then what we're going to do is we are going to do the 2's complement of the Y. Recall that when you go here, you have a negative Y, right? And let's come back to this. At this point, we have, let's say that Y is positive, okay? What we're going to do is we are still going to have to subtract Y. So we are going to take register 5, which is Y, and we're going to knot it and put it into register 7. And now at this point, the 1's complement of Y is at register 7. Then we're going to take register 7 and we're going to add the 1 so that way we can complete the 2's complement, which makes register 7 as negative Y. Or negative, I should say, R7 at this point is going to be negative Y. Okay. And so what we want is we want to still operate X minus Y if for the absolute value of Y. Why are we doing this? Because at this time, right, you have to meet these criteria. You have to say absolute value of X minus Y is greater than 0. Absolute value of X minus Y is less than 0. Absolute value of X minus Y is equal to 0. So we were handling absolute value of X and absolute value of Y, but we still have to subtract them, the Y's, okay? And check for these conditions. These are what the problem asks us to do. So we are looking at, you know, positive and negative and so on. So this is what we're working with along with this, okay? So coming back here, I have negative Y ready, and I want to add it back to the X. And so what I did was before, you know that register 4 was the X, okay? So what I want to do is I want to take X minus Y and put the result in register 6. Now remember the Z criteria, this is where we're going to branch, okay? When it's greater than 0, we're going to branch for positive, and we're going to send it to POS. And so it's going to check X minus Y. The result of that is in R6. And if the content of R6 is positive, it's going to go to this label. If it's not true, then it's going to go and check this. So if the content of R6 is 0, then it's going to go to the 0 section or the label. And then if the content of R6 is negative, it's going to go to neg. Okay. So you cannot put P and Z together because they are all different section, right? We want it to do different thing, like we want to output 1, 2, or 0, right? So what we want to do is we want to have the condition so that way we can display, right, at the memory address a certain value based on the met condition, whether it's positive, 0, or negative. Any question?
I have a question.
Yeah.
Our break, sorry, not break. Our branch statement always goes directly after the statement we want to check the condition of.
Yes. So in C++, you say if X is greater than 0, right? Do the stuff below. So in LC-3, the checkpoint, like greater than 0, is here. It's the previous line register, destination register. It's going to look at the destination register from the previous arithmetic, the previous instruction. So it's going to go here. If it's greater than 0, it's going to go to this label and it's going to do something there. That's the body. This is the body of the if. The label
Okay.
store the body of the if, and the destination register from the previous line. That's the condition that's going to check.
All right. Thank you.
Any other question? Okay, so as we have these labels, now we got to define, right, the body of if, the label. Okay. So positive, this is going to be x minus y is positive. Remember that I use R6 here, right? And I need to clear because I need to reuse some of my register. It's already able to check here, so I can clear it in my label. Okay, so it's already checking here. And if it is, we can clear the label. I mean, we can clear the register 6. And then what we want to do is remember that the questions tell us if it's positive, we're going to show a 1. So we simply just add a 1 for our z. So we are going to just add a decimal 1, or you can use a hex 1. It's the same. So we're going to add the 1 to register 6, and we're going to store it out to z. We're going to show that z is 1 when, you know, x minus y is positive. That means that x is greater than y. And then we're going to stop it for that label. Okay, these halts here are specifically for the body of the condition. Okay, not the entire program. Now, you know, the condition, there are 3 criteria that's checking for positive, 0, or negative, right? So if it's true for the positive, it's actually stopped. So we put a halt under the body so that way it stops there. Okay. Now, again, for the 0 label, if x minus y is equal to 0, that means that there are the same value, x and y. We're going to clear register 6. Like I said before, register 6 value has already been evaluated before it goes to the label. So we can clear it. And then what we want to do is, I put a 3 here, but let's follow the question. You're going to put a 0. Okay. You can add the 0 to register 6, so we can store it out to the label z, because the original question actually asked for that. I somehow changed it to 3 because I probably think that it was, you know, easier to kind of see 3, but you can add 0, whatever value that you want to indicate there. So when I show a 0, I know that x and y are the same value. And then after I add the 0 to register 6, I store it to z, so that way I can see z. If z is at that address, if it's a 0, then I know x is the same as y. And then I halt. Then now what we're going to do is we want to see if it's less. So for the neg or the negative, x minus y is negative, then we're again going to clear out 6. So you're going to see the pattern, right? It's basically the same procedure, but you are going to indicate different value to output for the condition. So I clear register 6. Then I'm going to add 2 decimal or hex. It's the same to register 6, because I want to show if it's a 2 at that address, I know that x is less than y, as it is a negative value. And then I would store that out, the number 2, to z. And then I halt. So we are going to then go to the data section. We are going to fill x at hex 3120. That's what the program the question asks us to do. Y is in the subsequent. Now, if this is not given to you, you make that choice, right? You don't want too far in the memory array. You want to be, you know, kind of close to where the end of your program is. So 120 lines later, that should be all right, right? So we would do at this address and then the next variable at the subsequent address. You don't want it too far apart either because it's just hard to see for you to check, so it's less confusing. And it's a good practice. Then earlier we have a label XMY for X minus Y, right? So it is at 3122. The absolute value of X is at 3123. Absolute value of Y is at hex 3124. And for the Z is at 3125, and that's the end. So the earlier question is, how can I make a negative value become an absolute? Remember that when you treat it, you are actually treating, let's come back up here. Where is it? Right here. So let's say that I have negative X, like -5. Okay. And what I want to do is, this is only going to check for the positive value, right? So when I store this to apps and it copies this, it's only going to go for the 0 positive in this. So in that, what we do is, when you take a negative value and you apply a negative to it, it's going to treat it like a positive. So when you choose complement it, right, it is going to be positive. That's after it checks for the 0 positive. Now, if I have a positive value, 5, it's going to check positive here already. So in that case, it's going to not go to the section anyway, right? It's going to branch to ZPY. So in the case where if I have a negative Y, this is not going to be met, and it's going to go to the next line and it's going to apply the negative value to make it a positive. That's how you treat an absolute value. Because if I have a negative to start with, right, it's not going to meet the ZP. It's not equal to 0 and it's not positive. So it's going to skip that label. It's not going to send it to the label, and it's going to go and subtract it. So when you take a negative value, subtract and apply a subtraction, it's a positive. And that's how you apply absolute.
So if we have like a negative X, it's going to skip this branch right here and it's going to knot it again. It's going to make a positive, right?
Yes, that's correct. And that's makes
and
it
that's why
absolute.
that's why we start right here, the positive already. Okay.
Yeah.
That makes sense.
Okay. So in the program like this, you really have to really break it down to some of the. So when we're building a function, you have to think about how that function operates with all the criteria. And so you have to break your algorithm into subpart and really address some of the subpart, right? The arithmetic equivalence of how you would treat an absolute value, and then make it could be a negative inside the absolute value sign. So in the question, what I did was I just go step by step, right? I make X, I make Y, I take X minus Y, I make absolute value of X, I make absolute value of Y. I take those and I subtract and I check for the 3 condition: positive, negative, and 0. And then I fill out the addresses so that way I can go and check and set the value for X set the value for Y before I run the program. And then I would be able to go to the other location to check. Okay. Question. Okay, so let me come back to my code. Let me see if I have, I'm just going to change this to a 0. All right, then we're going to save. And then what you're going to do is you assemble, for those of you who use the online simulator, right? Open the assembler, copy and paste your code, assemble, set value before you run. Then you're going to open up your simulator, load your program. Let me put this over here. And then if you're using the Windows version, you click this, right? For the online one, you just search for the address and then you type in the hex value. Remember, your simulator uses hex value. Okay. So I fill X at 3120. So I'm going to go to that location. So hex 3120. And then I put in a value. So let's give it a 3 or hex 3. Just going to type the lower X. And then I can set Y. I'm going to give it a 5. Okay. And then that's it. You just need to set X or Y. Set X and Y. And then you run. Now there's not going to be output in the console. So we don't need to look at the console. What we're going to do is we're going to do a jump to 31. What was it? 25. Or you can jump before. Let's do a little bit before so we can see everything. 22. Okay. So you're not going to see anything at 22 because that was just a minus operation there. So you're going to see here is my absolute value of X, absolute value of Y, and then my Z, which tells me it's a 2. 3 minus 2, X is less than Y, so it shows me a 2, and that's correct. Okay. Now I'm going to reinitialize and test it with a different value. So let's reinitialize the machine, reload the program. Well, you don't want to reset the value while it's like that because sometimes it still keeps the same value and you might not have the results. So if you want to test with a different value, reinitialize it. Or when you're using the website, just open another tab and then redo the process. It's a little bit more lengthy, but so I'm going to go ahead and set the value before I run X 3120. And then let's say that I'm going to give X is 7, hex 7. And then for the Y, I'm just going to give it like a 2, hex 2. And click OK. Then I'm going to run. After that, I'm going to go look at my address for the result. So hex 3123, let's say. So X is 7, that's the absolute value. Y is 2. And then I have a 1 because X is greater than Y. So it's correct. So in this program, you learn how to use if-else statement in assembly using branching, negative, positive, and 0. Any question? Okay. So as you complete this, Okay, after you write your code and add your comment, give me a screen capture of your code and your output in your simulator. Make sure that you set value for X and Y at hex 3120 and hex 3121. I put down here that you should step over. That's fine if you want to. So instead of run, right, I can use these buttons, and on the online simulator, they do have a step through. So you can use the step over. This is just going to go line by line so you can see. It just teaches you, if you troubleshoot when you test code or other people's code, sometimes you kind of have to look line by line to check your result, so you can do it like that. But it's not absolutely required. I just show you can do it. And then you can also set breakpoint and so on. Okay, but for the screenshot, I just need code and output. Okay. And I also put the don't run the program unless you set it for a certain value, and then you should test it. These are some of the values I recommend that you can test. Okay. Now remember that it is hex value. So if you decided to use larger value like 10, 12, 11 in decimal, remember that it's A, B, C. So just treat it like a hex value and you're good. And then for the negative values, right, you can punch it into your programmer calculator and you would find the F, hex F, whatever, right? That will be a negative value in hex. So you can use that. The simulator will take negative decimal, but for the hex, just make sure that you treat it like a hex. Okay? Not a decimal as hex. So test your program with different values and make sure that your program is accurate. The program is as accurate as its programmer. So sometimes, like you saw before, there are limitations in certain program, right? So what we want to do is we want to find ways to either improve the functions or improve how we access the data or data structure in our program. Okay, any question? Okay, so with that, we're going to do a similar program. And this one, instead of outputting the number like the last one, you're actually taking the result and you're going to either add, subtract, and so on. So it's a little bit more complex. The reason why I want to do this is I want to make sure that you understand how to use branch, and it forces you to apply what we've just learned, but elevate it a little bit. Okay, so I'll walk you through exercise 2. So let's talk about exercise 2. We have a P and a Q. P is at location 3200. Q is at hex 3201. We have an RES, which is our result, is at 3202. We're going to take P minus Q. We're going to check to see if it's greater than 0. If it is greater than 0, whatever is at RES, it's going to add a 2. Okay. So let's say that I set P as 4 and Q as 2. If I take 4 minus 2, right, and I output it in RES, so that's 2. And 2 plus 2 is going to show a 4. If P minus Q is less than 0, I'm going to take the result and I'm going to subtract 1. So we can't just store it out to the result and call it a day. We have to operate the addition and subtraction and addition again, right? So if I have P is 4 and Q is 5, 4 minus 5 is negative 1, right? And then I subtract 1, that's negative 2. For hex, right, we want to show negative 2 in hex equivalent. and that's going to show at RES. And then for the next one, P minus Q is 0, right? If I have 2 minus 2 is 0, right? So that's going to be 0. I'm going to add a 1, so it's going to do a +1 there. Okay, so it's going to show a 1. Any question? All right, let's take a look at the code. Let me see. For number 2. Sorry, with my big font, I think I did this a while back and I want to make sure everybody sees. So, all right, just like the last program, you can comment out the top to put those things, or you can just start your program, just put, so I'll do that. Let's do that. This is exercise 2. Origination address is at hex 3000. Oh, wait a second. Hold on. Give me a second, okay? I change up some of the requirements, so I want to make sure. AB star. I'm looking at the wrong folder. Sorry. This is the one. I apologize. I looked at some of the old stuff that I had from a while back and I modified the requirement. All right, so here is our program for exercise 2. Origination address hex 3000. I'm going to clear register 1 because I'm going to use that for P. I'm going to do an indirect load for label P to register 1. And next up, then I'm going to go ahead and clear register 2 for the next variable, which is Q. So once I clear register 2, I can load Q to register 2. And it is, again, an indirect load. If you like to use direct load, you can. We talked about this in the lecture, right? If you do LDI at the beginning, you STI at the end. If you do LD at the beginning, you ST at the end. So I'm using LDI here to load Q to R2 because I'm gonna, just like the last one, I'm not using absolute value in this one, right? But I'm gonna do P minus Q. And with that, we're gonna get ready to subtract Q. So we are gonna set up the 2's complement of Q. So we are going to not register 2, that is Q, and put it on register 2. That is the 1's complement, and that's at register 2. After that, I'm going to add 1 to complete the 2's complement. And so here's the 1's complement, add it with the 1 and put it on register 2. So register 2 has minus Q. Then I have a third label based on the problem. I have a label called RES for result. And so therefore I could clear register 3, but I'm just going to go ahead and load it to register 3 here. So load RES to register 3, and it is an indirect load. And so once I have everything, what I want to do is, wait, let me think about this. Actually, you don't even have to do this part. Yeah, you can omit that. Sorry. You can store it out. You don't need to load it. That's just an extra process that we don't need. So sorry, retract that last one. So after you have the complements of the 2's complement of Q, right, which is minus Q, we are going to take P, which is at register 1, subtract Q, and store the result in register 3. Because we're going to store it out later, so I don't really need to load and then store it. It's not necessary. Okay. So once I have register 3 stores the result of the subtraction, it's going to check the value in register 3 for positive, negative, or equal. So just like the last one, I'm going to do a BRP for positive, and I'm going to send it to positive or POS. So if P is, subtract Q is greater than 0, go to POS. And then if that's not true, it's going to go to the next branch, and it's going to check the content of R3. Is it negative? If it is, it's going to go to NEG. If that's not met, it's going to go back and look at register 3. Is it 0? If it is, it's going to go to equal. And you want to use a label that indicates the meaning of that process. So we want, or that sub process. So we want to send it to the right label there. Now you can have POS and do this, or you can have it and tab it, right? So you can have it on the same line, and that's okay. LC3 is not, assembly in general, it's not that particular. It's really for you on how you want your code to look, where it's easy for you to track. So I had it on the same line on this one, but if you prefer it like this, that's fine. And you don't need to tap this. And sorry, when I had it, just make sure it's like so. So what I'm going to do is coming back to the requirement, right? It tells me that I'm going to have RES, and I'm going to add 2 if it's positive. So here in the positive, I'm going to take the register 3, which stores the result. I'm sorry, register 3, which store the result, and add it with hex 2 and put it back on register 3. And then I store it out to a label called RES so I can see. And then I halt.
We're not clearing our, never mind.
You can. If you clear, it would have been, yeah, it would have been earlier, like right here. Right? That's optional. Yeah, but if you clear down here, then it just take out the value. So you gotta clear right before we add it. I just added this, so I'm gonna highlight it. It's optional for you. So we take the result, we put it in register or RES so we can see, and that's an address. And we halt. So that's the POS section. Let me bring this up a little bit. Okay. So what I'm gonna do is I want to use register 4 for the subtraction, because the problem tells us that if it's less than, I'm gonna take the result and I'm gonna subtract 1. Right? So for the negative section or NEG, I'm going to clear register 4 because I'm trying to get the negative or subtract 1 ready. And I'm going to take 1, I'm going to add it to register 4, which has nothing because I clear it and initialize at 0. So I'm going to add 1 to it and put it on register 4. Then as I wanted to subtract 1, I got to set up the ones complement. So I'm going to not R4 and put it back on R4. And then I'm going to take the 1 and add to it to make it the 2's complement. And R4 is -1 or -1. And earlier before the branch, we have register 3 storing the result of P minus Q. So we are going to take P minus Q, which is at register 3, subtract the 1, and put it back on register 3. This is for a different condition now, okay? And then I'm going to store it to RES. You can call it something else if you want. Okay. But you get the point. So after we have the output, we want to see it in the address, at the address. Any question? And then after that, you halt. Okay, I'm going to bring this down to the next page so it's all together. So I can explain the equal section. So now what we're going to do is we're going to check it for 0, right? Because earlier we already branched for 0 and we sent it to equal. So what we're going to do is we are going to add the 1 to the result because that's what the question tells us. That if it is the same, then you're going to take 1 and add it to the RES. So what we're going to do is we are going to take the 1. You can use hex or decimal. Add it to register 3, which has P minus Q output, and put it on register 3. And then here is where I'm going to store to RES, and I'm going to halt. And for my data section, I just do p.fill 3200, q.fill 3201, and res.fill 3202, and I end the program. And just like the last one, before you run the program, you set P and Q. But keep in mind that this one already has the output is with the addition, subtraction, addition. So it's not exactly the output value. Okay. If you want to check step by step, you can add additional label to check that. But I'm just doing based on what the question says.
Can you show me the beginning of the program? I think I wrote a line wrong. All right, thank you.
You're welcome.
Was there an LDI for register 3 res result? I mean?
Yeah, but you don't need to load and store it, because when I load res to register 3, it doesn't really do anything, because after you set the value and run the program, it stores right after it loads. Do you see what I mean? So you
Yeah.
load a label to the register and you're not doing anything with that label. So it's just an unnecessary process, in my opinion. In the last semester, I tell them to load. You can, but it's not required. So you just use the register, and then whatever the content is, you store it out and fill it. So with the label, so that way it's fine. Yeah, you don't need to load it. Okay, you can, but I don't think it's needed at all. Yeah, we clear register 3 here, but you're not. The things we have to think about when we clear, right? Earlier you saw that we cleared the register because we reused them right in the label after it was used in the previous line. That was intentional to show you that you can do that. After it checks, it already branched, and then we clear it there. So you should clear it as, just to making assumption that maybe there's something there. If there's something there, you should clear it if you want to reuse it. If you don't want to bring the data in with it, then you clear it. Yeah, it's good practice to clear at the beginning. So sometimes some developer, they don't always clear register at the beginning, but you definitely should clear it if you don't want data from the previous process within it. Okay. And so with this, just to reinforce what we learned with branching, this is a simpler program than the last one, because the last one got absolute value, but you can still apply the same concept as what you done in the last one. I just want to reinforce the arithmetic side of the house along with the branching. So making sure that you remember how to do this. Okay. So today's lab is mostly focused in control statement and applying the operation instructions, and of course data movement as well. And as I mentioned before, you can load and store. Okay, so just like before, right after I have my program, let me see, exercise 2. I think I did a load on this one. Yeah, let me take that out. And then I can clear it. Let me save. So make sure we save it as a .asm and then assemble. Then we are going to reinitialize the machine, open the file. And then I'm going to set the value for P. So P is at 3200. So I'm going to go to the location hex 3200. And then let's do hex 4. Apply. And then subsequent location for the queue. And I'm just going to use the same 4. Click OK. Then we're going to run. After that, we're going to jump to, so hex 3202 to go to RES to look. And since it's the same, it does a 0 plus 1, which is a 1, and my program is correct. So you can test it with a few values and see. Remember that we have the result, add, subtract, add, right? So it's not exactly just the result. So make sure that you remember that when you look, because, you know, some student, they don't pay attention to that and they think it's wrong, but just look at what the program asked for and what you wrote as code. Any question? Okay, so we'll spend a lot of time doing lab with condition statement. We will work on loops pretty soon. So you see how a for loop is implemented, a while loop is implemented. Okay. All right. And so here, remember that I gave you as decimal value here. So make sure that you treat 10 as hex value, which is equal to XA, right? When you test it. And then the negative, treat that as a hex value. So you can always use your program or calculator. Today's lab is not too long. So what we're going to do is we are going to work on the next one if you don't have any question for number 2. So we're just going to do one more and we'll call it a night. This one's easy. Actually shorter. Okay. So number 3, it tells you to write LC-3 solving D plus C is greater than 10. C is greater than 10. Or C is greater or equal to 10. And we want to apply branching. Here you can set any addresses that you want for D and C and also the output. Okay. So let's take a look. Number 3. So when you look at this problem algebraically, we can think about like how we can treat this value, right? So in algebra, what we can do is we can move the 10 to the left by subtracting 10 on both sides. And so it will look something like this. D plus C minus 10 is greater than 0, right? That's math rule. And then subsequently, you can also think about like C minus 10 is greater and equal to 0 as well. So you can approach the problem that way. The reason why I do this is it's a lot easier to branch once you have the 0 here. Because I can simply branch for positive, branch for 0 positive here, right? So when you look at the problem like this, you think about, oh, how do I solve this algebraically? If I solve this algebraically, it will look something like this. Now, then you're going to think about how you're going to break it down to the subset. So load the label, right? Bring 10 in to a register, make it a 2 complement, add it with these variables, and check for positive. Done. If it is positive, show this, right? Show POS and then a value. Now on this side, because C is going to go in here, right? Let's assume that C is 10. 10 minus 10 is 0, right? Then D is greater than 0. So think about like how you treat this algebraically. But if you want to, and you have to look at the condition as C, this line, this thing as its own entity before you plug it into the other one, right? In math, that's what we do. So if I break it down to assembly, right, I already loaded the label in the last one for C. And then I have a register that already have a minus 10. So bring down that register, add these two together, check for positive and 0. Done. So when you look at this, the algorithm consists of, right, initializing the variable and applying that to the function for addition and subtraction. Same thing with this. Okay, so let's talk about that. For our code, start with the program address. So origination.org hex 3000. We are going to clear register 1. So take 0, add and it with R1 and put it in R1. And I'm going to use register 1 for the first variable, which is D. So I'm going to load that to register 1. And in this case, I'm using LDI for indirect load. And I clear register 2. So again, I'm going to end 0 with register 2 and put it on register 2. So register 2 has 0. And then here your R1 is 0. And then now I'm going to bring in the variable C. So I'm going to load C to register 2. And what I'm doing here is I'm tackling this, right? Just like how you saw in algebra, you say, oh, if C is equal to 10, right, then plug that in here. So I would take the 10, which is hex A, 10 in decimal is hex A, and C is already at register 2, so I'm going to add it. So right now, basically, I'm saying C is 10. Then I clear register 3. Now, there are two ways that you can do this, right? I re-added hex A to register 3. I can also copy register 2 to register 3, right? Because register 2 already have hex A. But regardless, you're still going to have one more line. So one way to approach is to take hex A and add it to register 3 and put it on register 3 because I'm trying to do D plus C. Or I can simply, right, take register 2 and copy it to register 3. Now, you can use register 2 directly, but I want to keep things intact in case I use it later. So I would normally copy. So in this case, I just re-added hex A to register 3. So register 3 have 10 basically. Okay. And why am I doing that? I'm getting ready to do this, right? And then this, and then this. So I'm getting ready to subtract 10 with register 3. So after that, I'm going to take D plus C, which is my equation. So register 2 has C, register 1 has D. So D plus C and put it on register 1. Or you can also use another register like 4. Like that. Okay. Then I want to subtract 10, which is hex A. I'm going to do the 1's complement for R3. And then I add the 1 to complete the 2's complement. So it's basically minus R3 or negative hex A. Or negative 10 decimal, okay? Now to check to see if C is greater or equal to 10, right? When you do comparison, when you have comparison operator like this, it's simply subtraction. So I already have R3 is minus 10 and R2 is C. So I add them together and I put it on register 4 so that way I can check to see if C is greater or equal to 10. So when we branch, we're going to go to positive, right? So if my C is 11 and I subtract 10, I should get a positive number. So that should be DP. I had NP there, that's wrong. So what we have here is we are going to check the content of register 4. So if my C is 12 and 12 and then subtract 10, I should have a positive 2 in register 4, right? And it's going to branch based on P is true. It's going to go to C pass. Then for my next line, I have register 1 as D plus C. And I want to finish it out with D plus C minus 10 because this is my equation here, right? That's what I'm trying to compare. Is this greater than 10? So for the next part, I'm going to take D plus C minus 10 and put it on register 1. And it's going to check the content for register 1. If it's positive, it's going to go to POS. So if D plus C minus 10 is positive, go to POS. Otherwise, else, if it's negative, go to NEG. Now in C++, we normally just have like, if it's greater than, right, we would say greater than, and then if it's less than or equal, right, or else it can check equal or, and so on. But in this case, we're going to check for negative. If it's less than or 0, go to neg. All right. Then for the positive, I clear R4. Or you can use another register like 6. And this is added. The program didn't tell me to do this, but I want to do this as a programmer so that way I can see if it's positive or negative. So just like the first exercise, I add a 1 to register 4 to show that it's positive. And then I store it to my result. Again, I'm using RES, or you can use something else. Z, T, whatever. And then halt. And then repeat the process to clear for the negative section. So I clear register 4. I add 2 to register 4. So if it's less than, it's going to show 2. And then I store it to RES again and halt. So that's for the D plus C is greater than 0. If D plus C is greater than 10, is greater than 10. So we subtract 10 and make it greater than 0. So then I have a C pass section earlier, right? So I got to define it. And you can do this before that part, but since I did this, I just want to go and define the label for it. So for the C pass, recall that we branch for, we're checking that C is greater or equal to 10, right? We send it when it's 0 positive. So I'm going to go ahead and take R1. So R1 up here was, D plus C. Give me a second. It's greater than equal to 0. R3. R3 is 10. R1 should be C. R2 is C. I think I made a boo-boo here. Let me fix it. 1 second, okay? So R2. It's actually R2. Because R1 doesn't make sense. All right, I got it. Okay, so coming back to the top, right? We loaded C to register 2. At this point, what we're doing is we're checking if C is greater or equal to 10. And if it is, it's gonna go and show that, right? So my C is this. And what I'm gonna do is I'm gonna subtract it. And if it is positive, then actually I don't really need this. Sorry. I just need to store it out. One second. Yep. Minus 10 is greater than or equal to 0. We check that here. Go to C positive. So if it's 11, and this is 2, that's 13 greater than. So it shows. Yeah, I'm trying to make it do something outside of that. So let's do R2 with a value and then store it out to RES. Okay. I'll explain why I'm doing that. Give me a second. Add the 2. I'm going to do a 3 here. Okay. All right. So we already checked for C is positive here. We don't need to check it again. We don't need to add it again. We don't need to subtract 10 again. So as we send it to a positive section, we have to let it do something. Now, an option for you is to load a string here and display C is positive, right? Or something, right? It has to execute something. So when we send it to positive, what I did was C existed in R2. I simply take that value and add it with the 3 and then put it back here, store it in the RES so we can check the value. The value will exist there, or even when you can even add a 0 here, right? And then store it in an RES. It doesn't really matter. It's going to show that C is this. So if you add it with a 0, it's going to show C as a result or at RES here and store it in RES. So you can store it to something that you can see. Okay. So the whole point in this is we're going to plug C into equation anyway, and we're going to use that equation to compare. So we already compare C, and we're going to take that value and plug it into another equation. This is just for the developer to check to see if that's accurate with the check for the comparison. Okay, So you can do something with this here, and I chose to maybe add a 0 here so I can check the C value. And then maybe store it. Let's not call it RES because that's confusing. Let's call it CVal or something like that. And then I halt. Okay, then we're going to fill D at hex 3150, or you can do 3200, 31, whatever, right? C at hex 3151, and then C val, and we're going to do a dot fill at hex 3152, and then RES we're going to do at fill at hex 3153, and we're going to do a dot N. Okay. So let me bring this down so you can see it together. Question? Now, there could be other ways to approach this, right? What I did was I tried to solve it algebraically. I take the main equation, I subtract 10 on both sides, so I can check it against the 0. So that's how you can compare using comparison operator. And then I have to check for the C value that's greater or equal to 0. Now, in more of a complete program, that plays into other things like what does C really mean when it's greater or equal to 0. So, and then we take the C and we plug it into the main equation and we check it against the 10. So there's two comparison process in this, where we take a variable and compare it to a value. And then we take a sum of two variables and compare it to a value. Any question? Okay, so once you have the program, save it at a .asm, assemble it, set the value for D and C, right? Remember that you're checking against positive 10 decimal. So you can set the value for this. So let's say that if I have C is 10, right, and D is 2, so 2 plus 10, that's 12. It should check greater than 10. And for those of you who are fancy, you can also do an LEA to a string, and you can you can do an out to the console, and if you can show, D plus C is greater than 10, you can do it that way too. Or you can use the address to check. Okay. Now remember that when we use decimal, you set the value, it is in hex. So would that be equivalent? So as you use hex A here, you can use hex B, hex C for C, right? Because the criteria is to C is greater or equal to 10. Now, coming back, I just realized something. Yeah, you can also show the value itself by adding 0 instead of hex 1 there, but that's up to you. So for my result, I just show the 1 that's positive and 2 as a negative. You can also show the actual result if it's positive, and the actual result if it's negative by replacing that value with 0. Okay, and then because you store it out, you should be able to see it. Question? Okay. All right. So I think so you can open your program. Let me see if I put that into. I think I only wrote it on here, but you can build it, assemble it, and then run it, and then give me the screenshot for it. Okay. And then you can test it based on, so decimal 11, that's a B, and then D is a 3, and then show that. Okay. Okay, let me stop recording. I'll stick around for questions.